Welcome to our webinar today, CANopen Motion Control, a CAN-based strategy for system design. Over the next hour, Dean Crumlish, who you've been hearing talk, is going to talk us through the basic components and the thinking that goes into building a CANopen-based motion control system. Before we get into it, let me just do a couple introductions and some quick housekeeping, and then we can jump in. And let me just reiterate, go Dodgers for anybody that's tracking the American Baseball World Series right now. Just to introduce, you guys have been hearing us chit chat for the last few minutes, so you've gotten to know us a little bit, but my name is Jesse Poliato. I'm the Director of Marketing at Kvaser AB. Kvaser is a Swedish engineering company specializing in CAN hardware. CAN is in Controller Area Network, and also as in CANopen, which we're going to focus on today. With me from Kvaser is Tammy Purdy, who's General Manager for our Kvaser US office, as well as Troy Via, Technical Manager for the Kvaser in the US. Kvaser is hosting this webinar in conjunction with Copley Controls. Most of us on the call are familiar with Copley. They specialize in servos, drives, and motion control. The talk today will be presented by Mr. Dean Crumlish. Dean is a Senior Applications and Product Manager at Copley Controls in the Boston area. He's also an avid kayaker, so if you want to get him talking, you can email about that later. With Dean from Copley is Anthony Redimonti. You can see his face up on the screen right now. Anthony's a software applications engineer. So I'd like to welcome everybody. We have people from all over the world, as well as a number of universities. So if you're a student, welcome. Hopefully this will help you in your current studies and beyond. And then just two quick housekeeping notes, and then Dean will hand it over to you. If you'll notice in your Zoom screen, there's both a chat and a Q&A feature in the bottom of your bar. At least it should be in the bottom. If you hover, I think it'll pop up. Chats work the way all chats do. Feel free to chat the presenter, chat participants, the panelists. But if you want to make sure a question gets answered, use the Q&A function. The chats can tend to get buried in just the endless scroll of chat, and the threads get messed up. But in the Q&A, it's much easier for our team to answer anything. And if we can't answer it in real time, we will follow up afterwards and make sure you get an answer after the webinar today. Tammy and Anthony and Troy will be active in the chat, so you'll probably see their names pop up there. And the session will be recorded, so we will send that out, not immediately, but probably take a few days to process the video stuff, and we'll get that out to you as well. So without further ado, I will hand this over to Dean and let him take it away. Thank you, Dean.
Thanks, Jesse. Yeah, Dean Crumlish, Copley Controls. I'm here with Anthony Redimonti, who's software applications engineer, and Troy Via, who's Kvaser support engineer. And from time to time, I may ask them questions, but we'll stop the other screen sharing. Do you want to continue? Yes. So this is a Zoom meeting. I use Teams normally, so I'm just kind of coming up to speed here. So yeah, CANopen, motion control. It's CMO software for CANopen motion control. It's free software. And the Kvaser Mini PCI Express. I'm going to show, how we're going to make a motion control system. So as Jesse suggested, like, why CAN, right? Why not a serial port? Why not just a button? Why not some kind of Ethernet thing? Some of the reasons that we like CAN, and many OEM customers have tried other things and keep coming back to CAN, like the automobile, right? We're not going to change that from a CAN network. So 35 years of experience with the CAN network. It's extremely reliable. It will forgive you if you violate the rules. It's the lowest cost network. You don't have to spend a lot of money on a CAN network. Sometimes the EtherCAT or Ethernet can be more expensive due to the parts and whatnot. So a lot of times we'll get a processor with CAN on it already. So it was free. It's small messages get processed faster than really big messages. It's, I'm not saying the other guys are wrong. It's just a fact. a small message is much easier to process than a very large message. Yeah, very forgiving for problems. You know, if you get a bolt of lightning, no, don't worry about it. You can retransmit. You know, you don't miss a beat. You don't have to spend lots of money. It's good for OEMs, and systems integrators get to choose. You know, if you get to choose what you're going to use, it's up to you, right? If someone else is making a decision for you and telling you you have to use something, then fine, you know, do what they tell you to do. But if it's your choice, right, you get to choose, and you could choose CANopen. So we're going to talk a little bit about a CANopen motion system based on CAN. This is like a recipe, right? So you've got a bunch of ingredients that go together to make something wonderful. Okay, so you've got a Kvaser mini PCI, an industrial PC, and they go together, and they connect to Copley drives with motors, assuming we have motors connected to it. We have some I/O, like Wago, the click and snap I/O that's could be on a CAN network. And of course, Copley makes a CAN I/O module for integrating into an embedded system with 74 I/O points that are programmable. So many ways to do I/O and motion with the Copley hardware and other open hardware like I/O. So CMO is Visual Studio's .NET, C# kind of software, and you know, under the hood is the CANopen DS402 protocol for motion control. Like, you don't really need to know anything about it because you've got this software that's makes it easy. It's at a higher level, but it's good to know what's inside. And of course, you know, a keyboard and a mouse and maybe a touch screen computer for pushing buttons when you do object-oriented, event-driven programming. So I'm going to move on to a basic system here. This system is a CANopen system with several drives. You can see, you know, from the master side, you've got a terminator. That would be a computer. And then that would run into one drive and then out from that to the next, to the next. It's sort of like a daisy chain. It's a trunk network. It's a long trunk with a terminator at each end. So there's a terminator at the master. It's not in the picture here, but you can see it in this drawing. 120 ohm terminator. Characteristic impedance of the cable. It's just Cat5, you know, unshielded UTP, unshielded twisted pair. The characteristic impedance of a cable is 120 ohms. So if you hit the terminator, then you have the same characteristic impedance and you get no reflections. So there'll be a terminator at this end, a terminator at that end, and everything will run at 1 megabit. So this is one of the ingredients here. It's the Mini PCI Express 2X HS V2. And it has 2 CAN channels. This card fits into your PCI Express, your Mini PCI Express port. And that allows you to have a CAN port on your, you know, Windows operating system. And then there's this little cable that Kvaser makes. One end plugs into the card, and the other 2 ends punch out to the back here with a CAN connection with a D sub. And this is a terminator, so it's plugged in here. I gotta ask the audience, is this, you guys sell this, right? Maybe Tammy knows.
Yeah, we do. This is Jesse over at Kvaser. Yeah, we definitely sell those. They're not very expensive, but extremely useful.
Yeah. So it's got 120 ohms in it, and it's nicely packaged, so it's very convenient. So if you want your CAN network system to work properly, you got to have termination at this end. So get yourself one of these for a properly terminated CAN network. Let's take a look at the specs. You know, of course, it's 1 megabit. You know, You could do 500 kilobits, so it's normal CAN bit rates. The default's 1 megabit for a motion system. If you had really long cables and you're trying to traverse great distances, then a lower CAN bit rate's fine. Wide temperature range, 20,000 messages per second. That's a very healthy message rate. So the software running on Windows will not have a problem with this. Frame error detection, galvanic isolation. I'm not sure what silent mode is. That sounds cool. Troy, do you know what silent mode is?
Silent mode is a mode that you would use for doing diagnostics. So it's a case where you would want to listen to the bus without actually participating in it. That includes sending ACK frames or error frames. So you're listening to the entire bus without changing the behavior of the bus.
So you could technically, with a 2-channel, you could have one channel be the master and the other channel just be a passive monitor?
Correct.
Oh, that's very cool. So if you get the 2-channel card, you have a built-in master and a built-in monitoring of the network too. That's very cool. Thank you for that, Troy. This is just a typical industrial PC. You know, it's a computer without a fan. This one is a Neosys, but the distributors tend to have a brand like Advantech or whoever they recommend. This one was used on a tugboat. You plug in your monitor and keyboards, and you can even hook it up to your corporate network. But out of the side here, there were two plates that were punched out, and the cable was put in. Coast IPC put this together for me with a power supply. They loaded the PCI Mini E. They loaded the CANKing software. They loaded the CMO software. They loaded Visual Studios. They loaded CME setup and tuning software on a Windows 10 platform. This is a 64-bit. They threw in the power supply, and it's a good system. I guess the Pentium N42000 is kind of, maybe the memory is a little low. Hey, Anthony, what do you think about that memory there for CMO? Is that a little low?
No, 8 gigs should be sufficient.
Oh, okay.
Mm-hmm.
So 8 gigs is good for a motion program.
Mm-hmm.
Okay, good. Yeah, I like this too because it ran on 24 volts. Moving on. Copley, of course, has a web page with you can search for CAN drives. You'll see a bunch of drives, and there's a data sheet. You get a connector kit, which helps you connect the motor. You get a serial kit, which helps you connect CME over the serial port for setup and tuning and monitoring while your CAN system's running. And then you get the ADP-NK, which is a UTP Cat5 cable with RJ45 and a terminator for one end, and then the 9-pin D-sub to plug into the 9-pin adapter here. So it's a CAN standard for the port, so you can plug right in, and you can daisy chain more drives, plug it in into one, out to the other. Kvaser has some really cool software for monitoring. Like Troy was saying, you can monitor what's going on while you're running your master. I actually ran this CANKing on a single channel and was able to monitor the message and create a CAN log. So the ability to log to a file creates a good log file for analysis. Anthony, I'm going to ask you again, what are the kinds of things we look for in a CAN log when we're having a problem?
Frame errors. Yeah, we look for you can look for timing issues. Usually you debug and reading PDOs, and so you want to know what the PDO mapping is on a CAN network. So you want to be able to tell when you're sending SDOs and when a sync message is sent. So there's all these different aspects to the DS402 protocol, and that's what you'd want to see in a CAN log.
Yeah, that's good. Thanks for that, Anthony. You know, if all of a sudden, you know, you stop seeing any messages for 10 seconds while Windows is going to check the battery, you have to make that checking of the battery a lower priority in your operating system, right? So normally motion control is the most important thing you want to do in your operating system. Maybe checking the battery is something that you could do less frequently and with less time consumed, right? So if you ever see a Windows operating system, you know, stop allowing the process to run for 10 seconds, then you'll see it in the log of all the messages. And as Anthony mentioned, the frame errors. So CANKing as a tool for counting frame errors. I'm not tolerant of any frame errors, right? You can run the system, and if you hit 127 frame errors in a row without any good messages, you get a warning limit reached. I say if you see one frame error, you have to ask, why did I get even one, right? Did I have a bolt of lightning? Am I arc welding? Did I forget to put the terminator in, right? So CAN is very forgiving. It will let you run the system without your terminator. It's not a good idea. You should have 0 frame errors over time, unless there's a bolt of lightning. The CANKing can also have a filter the messages. You can send and receive CAN messages. You can do timed transmission. See the history of a transmission list, generate traffic, and have a virtual CAN channel. Troy, I got to ask you, what is a timed transmission? Because I'm not exactly sure.
The time transmission, when you the history list provides the ability to retransmit a message that you've already previously sent or a block of messages. So one of your options there is to either send it as a single shot, just send those messages again once, or with a time transmission, you will send the block periodically. So select a group of messages from your history list, and then you specify the gap between each message and whether it's sent continuously. And it'll just continuously send that block.
Okay, okay. And traffic generator. What I think I've noticed in some Kvaser systems is there's a few more messages than I think that I would be normally sending out. Is there something that generates more traffic? That, you know, what could be going on if I see some messages I don't recognize as coming from our software?
Right. So you're asking for the purpose of the traffic generator.
Well, okay. You may answer that question however you like.
The traffic generator is there as a general test. Like if I want to make sure my hardware's just working without any other software, I can do a loop back between the 2 channels and shoot data for a while to see, you know, as I heat the equipment up, whether it's still working. And the other use for it is in my normal system, since I can specify the range of IDs, I can try stressing my system by increasing the bandwidth used on the bus with a range of messages beyond what are used by the system, and see how the nodes react to messages that they're not expecting.
Ah, good tool for testing things out. I like it. Thanks, Troy.
Mm-hmm.
CME software is the Copley software for setup and tuning. It gets your drive and motor up and running. Anthony, what can you tell me about the CAN and the address? Like, can I connect the CAN to this node here? It looks like a 0.
Yeah, 1 second. Sorry, I was answering some questions. Yeah, so you want to make sure that the node ID is non-zero.
Okay.
So
And why is that? Why doesn't 0 work?
I think it's part of the protocol that you have to have non-zero node ID, as well as none of them they all have to be different, right? So it's
Yeah, that's a good point. Everybody should be unique. So 0 is not a valid CAN ID.
Yeah,
1 is a valid CAN ID. So 1 through 127. So that gives us 127 nodes. And this is using a switch, so you can turn the switch on the drive to get the node address. You don't have to use the switch. You can program the value to whatever node you want that node to be. But this is the basic idea of the CME setup and tuning software. You can tune the current loop, make some moves, do some frequency, and you can prove out the mechanical system. And then you put it in a CAN mode and hand it over to the software engineer and say, all right, I've set up everything, I've done homing, you go ahead and program it. I'm going to talk about the DS402 protocol as briefly as possible. This is looking under the hood, right? So there's a bunch of messages on the network. You got PDOs, process data objects, which we map, 8 transmit, 8 receive. These are the important things that we need for the process of motion control. We also have network management messages, for initializing the devices, moving the state machine through the different states of pre-op and op and safe state. We can monitor, we can do resetting and stopping of nodes through the NMT. And there's a sync message. This allows you, actually a drive will send out the sync because its clock is probably better than your computer's clock and gives you a highly accurate synchronization of time across the network where everybody's time is like exactly the same, plus or minus a microsecond, except for when you travel into outer space. That's a separate joke, never mind. SDO, service data object, is for doing large amounts of data, right? Like I'm going to load all the parameters for the drive using a CCD file or FOC, file over CAN. SDO methods are used. It's a confirming message format. And by the way, if you used up all your PDOs that you mapped and you need to get some more data or send some more data, you can always use an SDO method, even from our CMO software, to read and write anything. And of course, there's the state machine. So the basic idea for this is there's an object in the object dictionary, a parameter or a variable that we need to set, like the target position. Where do I want to go? Give me the target position. It's a 32-bit integer of the position I want to go to. You need to set this parameter. And the software will also work on the control word, right? So the state machine, all the bits get set, you're switched on, you're enabled, you're not stopping, you go from pre-op to op, and you're in a mode of operation. The basic idea is the control word controls things. And bit 4 in the control word will update the trajectory and move to the target position. And then when the move is done, the status word bit gets set for motion done, and we can determine that, well, I ask you to move and I'm waiting for you to move, and you'll tell me when you're done, and the status word will tell us when we're done. This is an example of some default PDO mappings that are defined by the CANopen specification. This is not what we use necessarily. We can map whatever we want using our CML source code wrappered around with CMO. So the CMO may use a different mapping, but these are just default mappings. For example, the drive will receive a PDO. The drive will receive a PDO. This is drive-centric or slave-centric. So this PDO is the control word and the target position. So one message not only gives a new target, but also initiates the trajectory to make the move. And then, of course, coming back is like a status word with maybe the actual position, right? I'd like to display the actual position on my computer and when the move is done, okay? So many things can trigger a PDO to transmit. You can wait for the sync message, say after every 100 milliseconds or 10 milliseconds, whatever you set it to, don't flood the network. And then an event like, the input changes. So let me know when the input changes, or let me know when the status changes. So events can trigger messages being sent on the network. The other advantage of the 402 protocol for motion control is it's well defined in the spec for how to do motion. Not only can you set the target position, but you can do an offset to that. You can have soft limits, max speeds, and you can monitor everything from position, velocity, following air, and torque. That's enough about the DS402. We're going to talk about CMO. This is the Copley free motion control software. So you don't have to spend any money when it's free. You just download it and use it with Visual Studios. You could pay for Visual Studios and then compile it. Otherwise, it's just interpolated, interpretive, and you just run it, right? So the idea is you've got some experience with .NET or VB or C#, and we give you some examples, right? The first example is to check the status, right? The next one is how do you do some homing, basic moves, linking multiple axes together, setting off a thread with an event. So you could have event-driven semaphores and mutexes handling event-driven stuff. So wait for an event before you do something. You don't want to write blocking code and wait forever before you run the next line of code. Spin it off in a thread. You can do PVT, which is position, velocity, time. This example makes a circle by sending a sine and a cosine to two axes that help you make a circle. And so it gives you the points over time to accelerate, run, decelerate, and stop on that circle. And this is all done on the computer. And you may have a wave that you want to generate, like a heartbeat, or move in a way to create a wave, and you have your own path. So you can create a path using a PVT, and we'll do the polynomial cubic spline interpolation in the drive, and we'll be at a very deterministic position once every 250 microseconds, plus or minus a microsecond, across a distributed network. So very accurate. If you know your path ahead of time, you can definitely, stream it out and do multiple axes of coordinated motion in a very efficient way. Okay, so we're being very efficient with CANopen. That makes us better than the other guys that have to update the position once every 500 microseconds or 1 millisecond. Again, 250 microsecond in the drive. This is a form, okay? So when you look at the basic move example, it comes with a form, which is basically object-oriented, event-driven. You push the button, it does some homing. We can see an example of the code here. There's an x-axis, which has an address of 1. So you set the node ID to 1, and now you can create an x-axis. You create a CAN network and an x-axis, and then you initialize the network, and you initialize the drive on the network. So that's just the basic code that's behind like the loading of the form, right? So you run the form, a bunch of stuff happens, and then it gathers some data, fills the form, and you push the buttons. And you can change the velocity and accel, decel, and then push another button. We also have a trace example. So if you like the CME scope, you like all this fancy data that's in the scope, you can read that data from the trace. The trace example shows you how to trigger the scope to gather data, which you can then use in your own software to process the data, like MATLAB or whatever you like to use. You can jog. You can use an SDO to read and write anything. This is an example of reading and writing registers to use our CVM program, which there's an indexer program we can stuff in the drive to let the drive run on its own, and you can read and write to the indexer registers using an SDO method. The IO module is something we make, the little IO module, although this does conform to the DS401 for IO. And there's a layer setting service for setting node ID, and some templates for like C# and other programming languages. Anthony, I'm going to ask you, did I miss anything here? Are there more examples than what I see, or?
Yeah, well, we'll be rolling out a PVT example using that constant acceleration algorithm. Yeah, no, that's all of our basic examples right now that are in CMO. So yeah, that's free motion control software for Windows operating systems.
Yeah, I think we did something recently, like example 6. If we look in this folder, we'll see another one, PVT from file, right? So this is like making circles, but if we look in the folder, there's another one for if you give me a file. And I think what you're talking about is creating the PVT path from, say, a list of PT points, right?
Yep.
Yeah. Do we have any other examples we've created, like pulse at position or something like that?
No, but that's all. Those are all settings that are you can roll out and do using SDOs.
Oh, okay. So yeah, so if we have some features, hey, I know I want to do something I don't see here. We have some experience with, doing things that have, maybe it's not in the example here. Basic using CMO with Kvaser, you'll see in the example, right, the code behind the form. You'll have to, unloading of the form. There's a bunch of stuff that goes on with the CML. CML is like the C++ source code that's underneath CMO. CMO like compiles CML C++ source code. And so we can use it as a DLL in our Windows environment. Here's a debug level set to all. So it creates a log file of all the messages that CMO sends or CMO receives. That's not necessarily all the messages that are being sent and received, right? That's just the ones coming and going from CMO. There could be other messages on the network to and from other stuff. So using that CANKing, you could create another log to confirm if there's other messages that are generated on the network. But you create an AMP object, a CAN object. Once you create it, you can set a bit rate. This one's 1 megabit. That's what the drive default is. And the CAN port is a Kvaser 0. If you had a 2-channel CAN a card, you'd have a Kvaser 0 and a Kvaser 1. You initialize a CAN network. You could initialize 2 networks because you have a 2-channel. You could CAN 1 and CAN 2. You could put all your drives over here and all your that's like 250, 62, 2 times 127 nodes on a 2 networks. And you can talk to them, so you can do multiple networks from the software. Initialize the CAN network and then initialize the drive on that network. And then you can read from the drive to fill in the text box. What is the velocity? Well, let's read the velocity from the velocity loop screen, the velocity limit, and we'll divide by 10. So if you had 3,000 RPM as a limit, divide by 10, you'd have 300 in here. Excel and decel are read, revs per second, or counts per second. These are in like, not friendly user units, but in drive units, okay? You can convert though, so don't forget, conversion can be done in software. Homing, you can get the settings, you can start a timer, and there's a catch exception, right? Like something bad happened. Don't just close down the software, put up a message and display what the problem is. Or better yet, handle the problem, right? If you make a move and it fails, you get a catch, error, move incomplete. What do you want to do? Home again, make the move, remove the crowbar from across the motor wires because there's a short circuit. So you can program in what you want to do in your program when some event occurs that maybe you don't want that event to occur. Anthony, am I missing anything obvious in the software that I should mention, or is that just about covered?
No, that's how the that is how a program would start up a network, and that's Visual Basic language that you're looking at there. So we also have C# and that's for the two languages and CMO supports.
Now, I don't like to read manuals. I make it a habit of not, maybe I write a manual, right? But I don't like to read them myself. But is there a manual for this CMO?
Yep, the CMO programmer's guide.
Okay, and that tells us some really important things like, you know, don't target it for your phone or don't target it for your iPad. It's to be targeted for a PC or an industrial PC, right?
Yeah, Windows .NET framework tells you Visual Studio version to use.
Now, is this only for 64-bit, or what do we do if we have like a 32-bit?
Yeah, you can also you have the option of using x64 or x86. x86 is 32-bit.
Okay. You can run all three softwares at the same time, right? You can run Visual Studios as a master and run the system. You can run CME. This one's connected over the serial port, so we can monitor while we're using the CAN port to make moves. And you can also run CANKing at the same time. I saw that work. It was pretty amazing. I'm generating a CANKing log of data. Of course, CMO is generating a log of what messages it sent and received. And then CANKing can create one for all the messages that it sees on the network, no matter how small and insignificant they might be. So the ability to use all the software is pretty good. I'm going to keep an eye on my time here, but there's some videos. Anthony, if you could put a link to the latest posted video in the chat, that would be useful. But it's in the presentation too. It's just step by step how I got the system up and running. And this is what we had at the SLAS show in San Diego, along with the Internet of Things. I'm going to talk a little bit about some software that's not free. Well, after you pay the license agreement, the one-time license agreement, then it's free, but it's source code, okay? This is C++ source code. This is not for electrical engineers like myself who didn't go to school for C++. Well, I could probably figure it out if I had to, but I like Visual Studios because it's easy, right? But if you're a code warrior and you like C++ and you're going to do it on an embedded system or something, this is the source stuff, but you got to pay for it. And then you've got to, you know, it's your own source code now and do whatever you want. You can't ask me, you know, how come my system doesn't work, right? But the idea is CML can do everything CMO can do, except for more things that maybe we haven't put into CMO yet, okay? So things like path planning is in CML right now. And so I want to go from point A to point B. I'll do it online, an arc, a curve, an arc, a line, and then I'll stop. So the path planner in CML can be used to generate a path to avoid obstacles if you know your path ahead of time. Now that's a little bit different if, you know, Alexa's driving you to work and some truck jumps out in front of you. Then you need to use Anthony's constant acceleration software to alter your path while you're moving, right? So maybe it's easy to generate PT. I can do position and time once every millisecond. Well, don't flood the network with unnecessary information, run it through the constant accelerator and come up with a PVT, stream it down to the drive, and you could do, you know, 8 axes of coordinated, highly synchronized motion using PVT with 1 millisecond update rate, right? And you know, it's kind of like robotic control. Now, when you get into 40 axes of motion control, not all of them have to be PVT. Some are just simple point-to-point moves. So CAN lends itself really good to applications that have a few highly coordinated axes and a whole plethora of simple point-to-point moves with, like, I don't know, 300 IO points. Okay, so all that's fine on a CANopen network. So there's a path generator in CML, which maybe someday we'll do something in CMO. And, you know, creating obstacle avoidance is kind of you got to hook up a bunch of sensors so that you can see where stuff is so you can avoid it, right? So that's not in the software, but you can use the software to make your own obstacle avoidance. Inputs, there's analog inputs on the drive for haptic devices like gyros and accelerometers. You can, a torque sensor, a load cell, a distance proximity meter. Haptic is the Greek word for sensing or feeling of something using your sensors. So any type of device could be fed into the analog input and then read over the CAN network, and then action could be taken based on what you're sensing. Pulse set position and position capture. These things happen in the drive, and of course you can access them through the software, as Anthony suggested, even from CMO. Basic types of applications that we see CAN in, a lot of these antennas, elevation, azimuth, the defense industry, it's very popular to use like a QNX operating system, Linux, RTOS. This is not for CMO, this is for CML. A lot of vehicles are using CAN. We have ruggedized drives or drives that are well made, even if they're like not very expensive, there's still benefit from all the testing we did in the defense industry, so they're very rugged. Motion control, C++, C#, VB.NET, these are typical for vehicles. Ability to, like a garment cutting, somebody else has a Gerber file to PT, and then we run it through our PT to PVT, constant acceleration. Anyways, you can have a knife that follows a path that you know ahead of time. In a gantry, you can have cross coupling in the drives and just send out, real simple paths. These semiconductor applications, like they all went to the, more costly EtherCAT, but it's still based on the DS402. And a lot of the systems integrators or people that feed into this industry, they're not forced to use anything. They use whatever they want, and CANopen costs less. So if you want to be competitive against somebody that spent a lot of money, CAN is a great way to do it. All the fancy features like dual absolute feedbacks, frequency analysis, MATLAB, all this stuff is available. And then you can use CAN to execute semiconductor equipment too, even if the industry trends towards other methods. I know a lot of robots like EtherCAT, but we're still doing it with CAN. Our OEMs have tested the EtherCAT and said, hey, why do we need to spend this money? We can do it in a way that's more cost efficient. Synchronization of multiple axes. Again, we can even do these new CSP, CSV, and CST modes of operation over a CAN network. So if you're on a real-time operating system, you could do 1 millisecond update rates. Over Windows, it's probably more like a 10 millisecond update rate, so don't get any ideas there. And then robotics, doing like a hexapod, where you have kinematics upstairs. We don't provide the kinematics, but if you have the kinematics, you can put that into the software and send out, CSP or CST commands and link up to 32 axes in a linkage so they can be moving together. There's a touch probe capability in the DS402, and you can run in torque mode. Of course, Kvaser has downloads for their CAN devices and their drivers. And of course, Copley has, this is where you download the free CMO software and the CME2 setup and tuning software from our webpage. Jesse, if you want to put into the comments where people download the drivers for the Kvaser, that would be very convenient.
Yeah, sure. Actually, Tammy's been in the chat and in the questions. Thank you, Tammy, so much. Tammy, if you don't mind grabbing a link for the downloads page on Kvaser.com, you can just throw it in there.
Yeah, so.
Sure, will do.
Thanks.
when you get one of these CAN devices, right, you know, it's got firmware on it. You know, if it's 10 years old, I'm not saying this is new, but if you have something that's been kicking around for 10 years, you might want to update the firmware. And then on your operating system, you should have drivers, right? So Windows drivers, load the drivers, and then when the card plugs in, Windows will see it and the drivers will be there, right? That's how Windows works. It shares stuff on the operating system. Same thing for Linux and stuff too. That's just a different operating system. I'm going to direct you to the distributors that Copley and Kvaser have. So Axis New England and Axis New York. So in the Northeast, we have a distributor who helps select motors and drives and Kvaser hardware. And Josh is a contact person, is a phone number for Axis, and they have a web page. So you can see our products there, and they can help get a quote, right? They can help find a motor, right? Copley doesn't make motors. Kvaser doesn't make motors. There's lots of motors out there. The distributors have good motors, right? It's not something you get off of Alibaba that doesn't work. It's something that, you know, is used by real OEMs in real applications and has to last for a while. G&G Technical is Mid-Atlantic, and you can contact them for, you know, the distributors have software engineers that can help configure stuff for the large OEM. You know, if you and me have to make a test fixture for a single test, well, then we'll have to do it ourselves, right? Because we're only going to buy one. But if we do 10 a year or something, then maybe that's good distributor business. Of course, if you're going to buy 1,000, let me know, right? I'll help you there. But again, our distributors, not only do they know Copley, they know Kvaser, they know CAN, right? They've been trained in this. So West and the Southwest, Olympus Controls, APC Automation and Process Controls in the Midwest, the Chicago, Minnesota area. These guys have used CANopen in many OEM applications, and they're very good at helping support the product. And of course, there's guide automation in central Midwest, like St. Louis, Missouri, a little bit further south too. Joe's a really good mechanical, electrical, and software engineer. Rodilec for Canada and upper Midwest, and Volker is at Electronics in Europe. They're located in Germany. So these are the distributors which can help, you know, help quote and get hardware ordered. I don't know how to process an order. I'm just an applications engineer. So, yeah, I'd like to thank the participants. I see there's 560 participants. That's pretty good. Jesse, if you want to take over from me, I think I've used my allotted amount of time here.
You've used it well. This has been great, Dean. Thank you so much. Thanks, Anthony and Troy, for kind of bringing so much information together.